Hello and welcome to another one of my webcasts. Today I'd like to talk about linear regression. But before I get on to talk about the nuts and bolts of linear regression, I want to talk a little bit first about functions or graphs in general, how we think about the maths of graphs, how we draw them, how we plot them, how we think about them. Hopefully if we remind ourselves of these sort of fundamental things, then when we come on to talk about the sort of nitty-gritty of linear regression, you'll find some of the more troublesome concepts will be a lot easier to grasp. Okay, linear regression. Linear just means line, it comes from the Latin meaning line. Okay, and here we have three different lines or linear functions, and these describe a relationship or a function between our x-axis and our y-axis. So they describe a relationship between the variable on the x-axis and the variable on the y-axis. So as we increase the variable on the x-axis, then how does the variable on the y-axis increase? And these three different lines are describing three different functions between these two variables. Okay, now before we get on, just to kind of give you something to glue or cement these ideas onto, I've taken the example here of exam marks, which are obviously very dear to your hearts. So on this graph here, I've got, on the x-axis, I've got second year marks, the mark you get at the end of your second year. And on the y-axis I've got your third year mark, so the mark you get at the end of your third year exams. Okay, so we would generally suppose that there's some relationship between these two things. Okay, so if you're performing very well in your second year, then we'd probably expect you to perform very well in your third year. So we'd expect some relationship between this variable and this variable. In other words, we're predicting a third year mark from your second year mark. And these three different functions are describing different kinds of relationships between your second year mark and your third year mark. They're going to make different predictions about your third year mark based on your second year mark. Okay, a general point as well to point out is obviously with a graph like this over here is the y-axis, and this over here is the x-axis. And the key thing to remember is that you always plot on the x-axis your independent variable, okay, so the thing you're predicting from. So in this case we're predicting from the second year mark, so that's going on the x-axis, that's our independent variable, okay. So typically you'll see on the x-axis things like time or age or stimulus magnitude, that'll go on the x-axis, that's your independent variable. And on the y-axis you'll have your dependent variable, or your outcome measure, or your response. The thing that you're actually measuring or you're interested in, your outcome, will go on the y-axis. Okay, so if you always get it that way round, it's a lot easier to think about. Okay, so these three lines here are showing us three possible relationships between the second year mark and your third year mark. Okay, so if we look at the third year mark, this third function, this is describing a one-to-one relationship between your second year mark and your third year mark. It's basically predicting that whatever you get in your second year, you'll get exactly the same mark in your third year. Okay, so if you got 40% in your if you've got 40% in your second year, then this model is predicting that you'll get 40% in your third year. Similarly, if you got 60% in your second year, then this model is predicting that you'll get 60% in your third year. So it's a one-to-one relationship. Okay. Now, when we're describing any function, any linear function, then there are two characteristics that we need to know, two values that we need to know about the function in order for us to plot it. Okay, and these two things are the slope and the intercept. Okay, now the slope is simply how steep this line is. Okay, so if you compare the function or the line for 3, the black one, with the blue one, you can see that this is a difference in slope. they are, function 1 is steeper than function 3. Okay? Now the other thing we need to know about any function is the intercept. And the intercept is simply, where does this line cross the y-axis? Okay, where does it intercept the y-axis? In other words, when x equals 0, what is y equal to? Well, you can see that for line 3 and for line 1, the intercept is 0. Okay, they both cross the y-axis at 0. Okay, so function 3 and function 1 differ from each other by their slope, but they have the same intercept. Okay, now if you compare function 3 with function 2, you'll see that they have the same slope. So you can see if I was to draw it with this ruler, function 3 has the same slope as function 2, it's just shifted over. Okay, so the difference between line 3 and line 2 is a difference in intercept. Okay, so line 2, the red function, is intercepting the y-axis at a higher value than function 3 and 2. Okay, so it has an intercept of 20. So in this example, that would be like this function 2 would be predicting that whatever you got in your second year, then in your third year you'll get the same mark plus an extra 20. Okay, so it's adding on an extra 20 all the way along. Okay, so these two lines are parallel to each other, the slope is the same, but they have a different intercept. Okay, so as long as we have a slope value and we have an intercept value, then that's all we need to know in order to plot the relationship between our x-axis and our y-axis. It's all we need to plot this function, the slope and the intercept. Okay, so the intercept's very simple. We just look to see where the line crosses the y-axis, or what is y equal to when x is equal to 0. Okay. Now the slope is slightly more tricky. In order to calculate the slope, then we need to use this little equation here. Okay. Now the slope is equal to the difference in y over the difference in x. Okay, or in other words, the slope is equal to the rise, how much it's going up, divided by how much it's going across. Okay, so the rise divided by the run. Okay, so what we want to know is for every increase in x, how much of an increase we're getting in y. That's going to tell us what our slope value is. Okay. So we want to know what the change is in y as a function of the change in x. Okay. Now if we calculate it for this function here, just find my razor. Okay, so to calculate this change, what we need is to look at 2 points on our line. Any 2 points will do because it's a straight line, it doesn't matter where we take it. And we need to look at the difference in y. So our y at point 2, at this point, at point 2, minus the y at point 1, divided by the x at time 2, minus the x at time 1. Okay? Okay, that sounds more complicated than it is, alright? If you think about a function, if you want to describe any point on this function, then we just describe its x value and its y value. Okay? So for this point here, okay, we describe its x value first, which in this case is 40, and then we describe its y value, which is also 40. Okay? So for any point on the graph, it's always the x coordinate, comma, and then the y coordinate. Okay, so at this point here, it's 40, 40. At this point here, well, our x is going to be 60, and our y is going to be 60. Okay, so we can call this is at time 2, and this is at time 1. Okay, so if we plug our numbers in here, okay, so our y at time 2 is equal to 60. Our y at time 1 is equal to 40. Okay, and then our x at time 2 is 60. And our x at time 1 is equal to 40. Okay, which gives us 20 over 20, which gives us a slope value of 1. Okay? So our slope for this line is a value of 1. And we know its intercept, where it crosses the y-axis when x is equal to 0, is actually 0. Okay? So if we have these two numbers for our slope and our intercept, then we can plot any function we like. Okay? As long as we know the slope and the intercept, we can plot this function. Okay? Now you can see, obviously, if I was to calculate the slope of this line here, then that's going to end up with being a higher number than it is here. Okay, so we're getting a much greater increase in y, for every increase in x. So this number is going to end up being larger. Okay, so steep slopes have larger slope numbers than less steep slopes. Okay, so that's how we calculate it. Okay, so this is all very well and good if we already know what the function is, if we already know what the slope and the intercept is, if we already know what the relationship is. But we don't always know what the relationship is, okay? And that's what linear regression does for us. Linear regression will take our raw data, so all of our marks, for example, all of our marks for the second year and the students' corresponding marks for their third year, it will take all of that raw data and it will fit a line to it. So it will give us a slope and an intercept. So then we can predict from that function, from your second year mark, what you're likely to get in your third year mark. Okay? Now the whole of linear regression uses a very simple equation. Okay, let's get rid of this. It's a very simple equation. It's y, so the value that we're trying to predict, which is on here, so in this case the third year mark, is going to be equal to a, which is just the intercept. It's a symbol we use for the intercept. Just write that there to remind us. Okay, so it's equal to the intercept plus b, which is the slope value, times x, which is our number here from the x-axis. Okay, so the whole of linear regression is going to give us some values to put in here so that we can predict what the outcome is going to be, what y is going to be equal to, depending on what the x value is. So in this case, predicting your third year mark, y, from your second year mark, x. Okay, so if we just do an example here, you can see how it works. So if we use this formula, and we plug in the numbers we've got here for our function 3, our black line, then we can work it out. So we want to know what y is going to be equal to. Okay, so we know our intercept is 0, so let's replace a by 0, plus b, which is our slope, which is 1, times, well, let's pick a number, a value off here. So let's suppose that you've got 60% for your second year. Okay, so it's going to be, x is going to be equal to 60. And if you work this out, it's going to be 0 plus 1 times 60, which is obviously going to be 60. Okay? So if I know what the slope value is, and I know what the intercept value is for this function, then I can predict y, predict your third year mark, from your second year mark by just plugging in the values. Okay? So this is all very well and good as long as we have the function. But if we've just got the raw data, then we don't know what the slope is. We don't know what the intercept is. And that's what linear regression does. It takes this formula, so it takes the formula y equals a plus bx, and from our raw data, it'll work out what these values are. So I can plug in my x value. So basically, I don't need to keep drawing a line every time I want to predict or calculate an outcome measure from my independent variable. I can just use this equation. This equation is functionally exactly the same thing as drawing a line. And linear regression will fit a line to your raw data and give you the intercept value and the slope value that describes that data. Okay, so I'm going to stop this webcast now and draw another diagram, and we'll talk through actually how we derive these functions in the first place from our raw data. Okay, thank you for watching.